going to be talking about. All right. Yesterday, or not yesterday, for us Wednesday, we talked about the rate of change of functions, where we had f of b minus f of a divided by b minus a, and then after that we sort of went into using the limits and having f of a plus h minus f of a divided by h, as h equals to 0, to find the slope of a function at a given point. All right. So what we're doing is, so while we were talking about rates of change, in math, the study of rates of change is called differential calculus. All right, and that's what we're learning here, the differential calculus. And essentially, calculus is broken up into two parts: differential calculus and integral calculus, which you learn in the second half of the year. All right. So Wednesday, what we did, and Monday, what we found was the slope of the function and tangent line at a specific x value. Right? Today, we want a general equation for finding the slope of f of x at any value of x. So what we were doing was, on Monday and Wednesday, we had to, let's say we wanted to find the slope at x equals 5, we would plug 5 into f of a plus h, or f of 5 plus h minus f of 5 divided by h, and then you have to simplify everything, find the limit as h goes to 0, and then you get a number. Well, then let's say you want to find f of negative 5. Well, if that's the case, we have to put negative 5 back in to that same limit as h goes to 0, and you have to do all that math all over. All right, and then let's say you want to find 1. Want to find the slope of f of 1, just do all that math all over. Find the limits and do all that all over. And to be honest, we aren't going to want to have to do that every single time we want to find the slope. Right? So what this brings us to is something called the derivative. Right? And the derivative is the function that represents the slope of the curve at any given x value. So what this means is, instead of finding the slope at one point, we're going to find an equation, a function that represents the slope at any point on the curve. So if we had any of those, if we had any function, if I wanted to find the slope at 6, negative 2, 5, 1, 0, negative 55, any of those numbers, I'm going to have an equation for the slope of that line, which we call the derivative, and I can just plug those numbers into the equation and quickly get the slope. All right. Side note, the derivative was the 17th century breakthrough that enabled mathematicians to unlock secrets of planetary motion, gravitation, and attraction. So, derivatives tell us how this whole system works. You guys are lying because of derivatives. All right. Seriously, if the derivatives didn't work the way they work, you would all fall from something back. Not me. All right. So, that being said, I think we need a definition of the derivative. And here's the surprising thing. You guys already know the definition. All right? The definition of a derivative is... That's like the wordy definition. And in calculus, the definition is typically math symbols. So, the definition of a derivative in terms of math is the limit h equals to 0 of f of x plus h minus f of x over h, which should look slightly familiar. Yes? Does it look familiar? It does, doesn't it? The only difference is that instead of having a, which, a was our point, we have x, because now we're going to come up with a function instead of an actual number. We're not plugging a number into this. All right? So, that is the definition of a derivative in sort of math language. Okay? Now, before we start talking about how to actually find a derivative of a function, there's some notation that we need to go over. Okay? And that notation, there's a couple different ones that we're going to see. All right, so let's say I give you a function f of x. All right, and let's say I give you a function f of x. So if you have the function f of x, when you find the derivative, you're going to call it f prime of x. All right, that's what you say. F prime of x, or that's the first derivative of x. Okay? So it is important to understand that that represents the first derivative, because you can find the second derivative, third derivative, fourth. My fault. I think it's just like a apostrophe. I don't. So like when we get to the point where we're finding like the second derivative, you have f double prime of x, or f double apostrophe. It's a good question. No one's ever explained it as a one to me or not. I think it's just apostrophe. If you put a one up there, you put a negative sign on it, it's being whole different. So another way, so we have f of x. Other times you might have this equation y. And we've all seen that. If you have y, when you take the derivative of y, what you're going to get is your arrow and dy. Yeah, which should look familiar because you guys have seen that before. Where do you guys see dy dx? In the calculator. It almost sounds like when we were finding the slope of a function at a point on our calculator, we were actually finding the derivative at that point. Imagine that. Craziness. Alright? And then there is one other one. It's not usually seen on anything that you're going to be working with, but there's almost like a function type of notation. It's the derivative of f of x. Alright? So is that d over dx? It's d over dx. So it's a derivative with respect to x of f of x. Alright? So the way to do this is the derivative with respect to x of f of x. Alright? To be 100% honest, the main ways you're going to see the derivative notation here is top. Alright? Now, let's say, I did say you can find the second derivative, third derivative, fourth derivative. In this notation right here, if you were finding the second derivative, you would write like d2y is the second derivative of y with respect to x. Okay. So, one other clarification I want to make. So when you're saying this, a lot of times what you'll hear or see is you want to find the derivative of y with respect to x. There's different times when you'll find it like with respect to t, in the middle of related rates, or you might have a different variable. So this is typically whatever variable is the function that you work with. Alright, so let's put an example. Okay. So we want to differentiate, and that's a new word. Differentiate means find the derivative of it. Okay? So we want to differentiate the function f of x equals x cubed minus x squared plus 1. Alright? Now, I know a shortcut, so that's sweet. You guys will learn the shortcut, not today. You guys have a few more days of having to go through the whole process of limits. And then after that, you'll never use that process again. Yep, I won't get you a lot of Now, what we do here, okay, so we need to go back. In order to find the derivative, we need to use the definition of the derivative right here. Okay, so this is going to be, so we need to find the limit. As h approaches 0, f of x plus h, and I'm going to show all my steps here, right? Minus f of x all over h. Okay. Now, as kind of being mean here, you get a x cubed. Makes my life more hard, makes your life more hard, more difficult. All right, but whatever. So we have x plus h. What are we doing with that? Where are we putting that x plus h? So I have to put it in for each x. So I have, so if you write this in the, again, I expect you guys to be writing the limit, and h approaches 0 every time. A little bit smaller here, we're going to be lots of things. So we're going to have x plus h cubed minus x plus h squared plus 1, right? Minus f of x. Now, I have to subtract the entire function of x. So just to be on the safe side, I'm going to put, see? Yeah. Actually, it's not the same thing. You have to be on the safe side. Ignore it and get caught. Minus x squared plus 1. So I'm going to be on the safe side by putting brackets around that. I'm subtracting that whole thing. Alright? I could put parentheses around that, but we're going to do brackets. It's going to be cool. All over h. Alright? Now, as Michelle just said, yeah, this x plus h cubed is sort of, you know, that is x plus h times x plus h times x plus h. Alright? So what I'm going to do is, I'm going to just do 2 of these for right now. I'm going to do x plus h times x plus h, because there's some kind of shortcut that allows you to figure it out real quick, but don't have that shortcut. So, what we have is equal to alright. So before we get started, we're going to go, we have this is equal to the limit of h approaches 0. Some quick math allows us to do x plus h squared in our head. So that's going to be x squared plus 2xh plus h squared times the explanation multiplied by. Okay. We also have minus x plus h squared. Well, we just did x plus h squared in the head over here, so it's going to be minus x squared plus 2x. I forgot something there. 2xh. Dang it. Plus 2xh plus h squared times x plus h minus x squared plus 2xh plus h squared plus 1. Now, just so I don't have to put brackets, I'm going to distribute this minus sign. That's just minus x cubed plus x squared. Oh, not mentioned. Alright. So, still not quite ready to simplify it. I still got this right here where I can multiply this trinomial by this binomial. Alright, so you have a little bit more writing to be doing. This is equal to, I should do that equal sign down. Or you guys must do that, you guys can figure out the shortcut later. You might even see a shortcut today. The only way you're going to see it today is you guys figure it out. So we have to multiply this whole thing. So x squared times x is x cubed. X squared times h is x squared h. 2xh times x is 2x squared h. 2xh times h is going to be 2xh squared. And then we're going to have h squared times x is going to be xh squared. And h squared times h is going to be h cubed. Okay, so we might even have space. So, let's distribute that minus sign. So we're going to have minus x squared minus 2xh minus h squared plus 1 minus x cubed plus x squared minus 1. You guys take that out of you all. And the whole thing is divided by h.
I had a question.
Yes.
How do you get 2x squared h?
Here?
Yeah.
So 2xh times x is 2x squared.
Okay.
Yes? Oh, that's a good question. Not x's. Oh, h's? Not yet. We will. Yes, we'll do lots of h's. Looks like everybody real fortunate. Now, before we do that, anything with h's, what we're going to look at is this. Well, I'm going to simplify a bunch of stuff. Okay, so first of all, equals the limit. Then you put to 0 and you put that down. Let's see if there's anything we can combine. Okay, so x cubed. Are there any other x cubes up there?
Yeah.
That's a bingo. The x cubed cancels out with that minus x cubed. Are there any other x squared plus h's up there? X squared h plus 2x squared h, that's 3x squared h. Any other ones? I don't see any other ones. So we're going to put 3x squared h. Which is nice. So, I'm going to just go ahead and I'm going to put a little squiggly between that and the green just so we know we used it already. Alright. 2xh squared. We have another xh squared here. That's 3xh squared. That's going one?
No, wait.
Yeah, that's one. Plus 3x.
But the other one's the same. Regular 2x.
Huh? Well, that's not saying that, is it? So let's squiggly line these guys out. Now you have h cubed. Is there any other h cubes? No. We're just going to put that right there. He's not regular. So we have minus x squared. Oh, plus x squared. There we go. Cancel stuff out. Then we have minus 2xh. Sounds good. I think that's a good thing to be having. We have a minus h squared. We have a plus 1 and a minus 1. Alright, so squiggle these guys out because we use them. Now notice. And this is going wrong. Pretty sure that after you do this part, after you cancel stuff out, simplify, you should not have any things that are just x's. Alright? Oh, not green. Red, because this is all divided by what? H. Alright, tomorrow, would you want to do that 7 seconds ago? Cancel out some h's, right? Well, that's awesome, because we have an h to cancel out, 1 h to cancel out, 1 h to cancel out, 1 h to cancel out, and 1 h to cancel out like that. So we have a limit of h approaches 0 of 3x squared plus 3x h plus h squared minus 2x minus h. Right? And h is approaching 0, so that means we can do how to find the limit of this now. Plug 0 in. So we're just going to plug 0 in and see what happens. So we're going to have 3x squared plus 3x times 0 plus 0 squared minus 2x minus 0. then this cancels out, because the x times 0 is 0. This goes away, that goes away. You're left with 3x squared minus 2x. And this is equal to f prime of x. Boom. I must sit down. That would be awesome. What do you guys think? I bet you I could have you guys do two other examples we did if you're not sure. Alright, so what does this mean? So we have the derivative is equal to, so f prime of x is equal to 3x squared minus 2x. Alright, so everyone have this written all the way down? Huh? Yes? So what I'm gonna do here, I'm gonna do this. I'm gonna put this next to the actual thing. The equation is done. Just that you guys observe here real quick. Function, derivative.
Okay, so I'm going to go
Okay.
So, but I don't get it, there's no one is a yeah, we're breaking 3 and 2. Oh. So, so yeah, I was saying, but it is really good that we just want to you just want to do is that it? Is that the short one?
Huh?
So say do a one. All right, I'm saying, so like, say we have.
I would say that you are on the right track. I think that what you just said is part, that's the shortcut, which you have to know. You have to know, like.
You used to say, like, why it, but I don't know, for the.
One way. So you don't know the one, and you said the first, the thing that you guys saw, the first was that the exponents each went down by 1. And then you were wondering where the 3 and the 2 came from, and then notice that kind of looks like you brought this 3 down here and this 2 down here.
Okay.
Alright, so here's what I'm gonna say. That is a shortcut, but you don't just bring the 3 and 2 down. Alright, there's a read. It looks like you just brought it down here, but you don't. It's not just bringing it down. And we'll do an example later today. So you have a few more to do. So before you guys, so we want to, so you find the derivative, that's cool, but you want to use the derivative. All right, so we want to use the derivative to find the slope of f that's at these points. All right, so yeah, so here's the function. We want to find the slope of x equals -2, x equals -1/3, x equals 5 for this function, but to find the slope, right, the derivative is the function that gives us the slope. All right, so all we're going to do here, here's our derivative. So we take -2, it's 3 times -2 squared minus 2 times -2. That's going to be equal to 3 times 4, which is 12. That's going to be -4 minus -4, so plus 4. So the answer here, the slope at x equals -2 is 16. And you plug -1/3 in. 3 times -1/3. third squared minus 2 times negative 1/3. That's going to be equal to, that's 1/9. 0 to 1/9. So 2 times 1/9 is going to be 3/9, which is 1/3. That's going to be plus 2/3. So the slope at x equals negative 1/3 is 1. And then x equals 5. Let's see. So this is going to put 5 in. It's going to be 3 times 5 squared minus 2 times 5. So that's going to be 25, 75 minus 10 is going to be 65. Say it again. Well, okay, so you're good, but also we're just evaluating the derivative. So you just have to know that if we find, so what we're finding here is we're finding f prime of -2, which is equal to 16. So if you just write f prime of -2 is equal to 16, maybe I should do that. That is the same thing as saying slope, because we know that the derivative gives us the slope of that function. So if you just write, so yeah, I guess that's a good point, Shamar. You want to write, like, you don't want to just write 16, I guess you want to write f prime of -2, f prime of -1/3, f prime of 5. Alright. Now, here's a nice thing. How do you know you did this right? Then you got to decide to use this entire time that you write down all that stuff or nothing. So, I'm going to show you guys 2 ways to figure this out. Okay, I'm talking about 2 ways you can check the answer. So, way numero uno. What do you want to be, what? I think this is actually, I don't got that. Alright, so, your face. So, here's 2 ways to do this. Okay, 2 ways to calculate the derivative and check the answer and obviously find the slope. So, way number 1 is you can graph. So you go y equals, and you have x cubed minus x squared plus 1. I'm going to graph that. So, my window doesn't look like this. I'm going to, alright. So, do you guys remember how to do this while looking at the graph? Second, not trace. Second trace. Then which one? 6.
Okay, wait.
Yes. Second trace. Second trace.
Okay.
And then we're going to choose, now, remember this, we know what this is now, this is the derivative, dy dx. Alright, so we have 6, and we're going to type in the value of -2. -2, and we get 60. Okay, so don't pay attention to the fact that it says 16.0001. That's just calculated being more special than we are. Alright, so then we can check -1/3. We're going to go second trace, 6. -1 divided by 3, and it gives us 1. Here it is. So yours you guys probably just said 1, right?
No, not that.
So why? I believe you took mine and I have yours.
No, I did that one. Remember I did. Look, here's the one.
Said yours was in the box.
Here's the one.
Well, then, does yours say float 3?
Yeah. Yours.
First doesn't say float 3, that's because she took mine.
Oh, no, don't throw them away.
That's a lady, let me tell you.
So, 5, second, trace, 6, we'll find the x equals 5, and you get 65. Alright, so, another way, I'm going to show you this other way, which is that it's a little bit quicker because you don't have to graph. So you're going to want to make sure you have this now. Because there are times when you have to calculate the derivative of something on the AP test where it's a very, very complicated function that you guys do not know how to find the derivative of because you just don't. Alright, you never will really need to because you have a calculator with it. So another way that you can do this, you can go hit math. Okay? And we're going to go over as another, oh, right there, there it is, stop moving. Alright, I believe it is number 8 on you guys' calculator. It says any derivative. Oh, which number is your derivative? Mine's not. Okay, so hit 8, and it should look like this. Alright? This makes this so much easier than the old school calculators. Alright, so this should pop up. Everyone pop up like this. Mine not just check. That's mine, right? Yeah. Okay, so it does. Alright, so here's what we're going to do. This should look familiar. The derivative of the derivative with respect to x is just as one of those notations I gave you guys, right? So x. Now, right here, you're just going to type in f of x. F of x is x to the third minus x squared plus 1, and you go over, hit the right arrow, and we want x equals, let's say you want x equals 5, just type in 5, hit enter, boom. Alright? Boom. It finds the derivative. You can type any function in there. And it'll find the derivative. Assuming it exists. Imagine that. That's pretty cool, huh? Alright. So using the derivative is pretty easy. That's just plugging numbers in. Alright. Do this one. Any questions so far?
No.
Nope.
Wait,
Good.
no.
Yep. Nope. Yep. Yep. Nope. This one. So, it says find y prime. So y is equal to 1 over x squared. So y prime is going to be equal to the limit as h approaches 0. It's going to be f of x plus h. So it's going to be 1 over x plus h squared. Minus f of x, which is 1 over x squared, over h. Okay? So, first thing I'm going to do here is I'm just going to go ahead and take this and expand that just to the heck of it. Limit as h approaches 0 of 1 over x squared plus 2xh plus h squared minus 1 over x squared. And then all that's going to h. Alright? So, in order to be able to combine that numerator, I need to have common denominators. Alright, so the easiest way to just do that is to multiply this by x squared over x squared and this by that over that. So we're probably making this a little bit more complicated, but we have probably done that a little bit earlier. So we have again, what I said, we're going to multiply this by x squared over x squared. So we're going to have a limit as h approaches 0 of x squared over, it's going to be x to the 4th plus 2x cubed h plus x squared h to multiply this by this, so we multiply this whole side by x squared plus 2xh plus h squared. X squared plus 2xh plus h squared. That's going to give me minus x squared minus 2xh minus h squared. And that's all going to be over the same thing. Right? So, now, that whole thing's still divided by h though. And so, when we divide by h, that's the same thing as multiplying by 1 over h. Right? So, here's what we have. Pull up a chair. And we're going to start looking at what might cancel out with this x squared, cancel out with that x squared. So we are left with this is equal to the limit as h approaches 0 of negative 2xh minus h squared, all divided by we have x to the 4th times h plus 2x cubed times h squared plus x squared times h squared. I heard this not reading like that. Is that a question? Question so far. So Shamar, what's going to happen now? Now, first of all, notice there's nothing up here that does not have an H. Good. Now, what's the first thing that's going to happen? What are we going to do now? What did you? Yep, because you both cancel out H's, so that goes away. One of those goes away. That goes away. That goes one of those goes away, and one of those goes away. All right. So at that point, we are left with this is equal to the limit. We're almost there. And h goes to 0 of negative 2x minus h all over x to the 4th plus 2x cubed times h plus h plus x squared times h. I like to do my x's and none of my h's. All right, now what do? What do I do now? Look at this, we're finding the limit, right? Right at that point, find the limit. So what do? Plug in 0. So we're plugging in there at negative 2x minus 0 divided by x to the 4th plus 2x cubed times 0 plus x squared times 0. These both cancel out. That 0 goes away. We're left with y prime is equal to negative 2x divided by x to the 4th, which sounds like, yes. Which, then we cancel out an x. We get negative 2 over x cubed as our derivative. God, this shortcut is so much easier than that one. Now it's the shortcut. We won't know. We can try it on So, what questions about that? Yeah, any questions? Maybe you can get home and go home and watch stuff. Alright, question about this. Yeah, 2x cubed times 0. Alright, you get it for one more? Yep.
Am I gonna be able to do it in this?
But now it's one small, you right. So we're gonna find the derivative of this. So that's this is that other notation that you see. So let's do this. So I guess we're just gonna use the definition of the derivative because you guys are not. You have a shortcut yet.
You haven't done the shortcut yet.
So here's what we do. We have d dx is equal to, it's going to be f of x to the limit as h approaches 0. F of x plus h is going to be the square root of 2x plus h plus 1 minus square root of 2x plus 1. Oh. Y'all are awesome. Alright. So, refocus. Alright, so, what we do here. Okay?
Wait, hold on.
What?
2x plus
Here?
Yeah.
What about it? X plus h. Remember, it's x plus h.
Wait, so. Wait. Oh, it's plus.
Minus. So this is equal to the limit as h approaches 0. That's going to be, I'm going to simplify here, 2x plus 2h plus 1 minus 3 of 2x plus 1 over h. Do you guys remember how to deal with square roots? The answer to C and mine is conjugate. Yes, conjugate. Good. How do you guys know? So, yep. So, what we're going to do is we're going to multiply by square root of 2x plus 2h plus 1 plus square root of 2x plus 1 all over square root of 2x plus 2h plus 1 plus square root of 2x plus 1. Alright? So, this is awfully nice of them. So this is going to give us, this is equal to the limit as h approaches 0. Now here guys, here's a quick little shortcut about conjugates. Alright? See how the square roots? See that? Yeah? See, just take the square roots off when you're done. You don't have to actually count. So it's actually 2x plus 2h plus 1 minus 2x minus 1. Imagine that.
I was going to put minus 1, minus 2.
You can see how it's minus this, so it would be minus 2x plus 1, so it would be minus 2x. Divided by h. Oh, I forgot about it. We have h, and that is multiplied by square root of 2x plus 2h plus 1 plus 2x plus 1. Why do I? Multiplied by the conjugate. So, this is equal to the limit as h approaches 0. That h comes out with that h. This 2x comes out with that 2x. This 1 comes out with this minus 1. So that means it's just a 1, 2 on up. Right? Yes. So we have 2 on top. Divided by. So we now have the square root of 2x plus 2h plus 1 plus square root of 2x plus 1. Well, they got 1 here. And we can now do what? That's a bingo. Which one? What are we doing? Yep, what are we doing now? Plug in our zeros here. 2 divided by square root of 2x plus 2 times 0 plus 1 plus square root of 2x plus 1. That's equal to 2 divided by square root of 2x plus 1 plus the square root of 2x plus 1, which is equal to 2 divided by 2 square root of 2x plus 1, which, 2 cancels out, you have equals 1 over square root of 2x plus 1. And there's a derivative, and there's so much an easier way to do that. But that one right there, I should have taken a little bit more time to get because it has a little bit of stuff. So you guys won't actually be able to learn the shortcut. That one for about another while. I would say probably a couple weeks. I'm just checking something. There will be a time and day when you get practice something like this in a practice. But derivative of the square root of x. Boom. Got it. Derivative of the square root of x. Okay, question about that. So here's the first of all, you guys, trying to figure out the shortcut. Nope. Yes, you don't have to have shortcut. So let's say we had the function f of x is equal to, we're not going to do 3x squared plus 2x minus 6. Alright, so we want to find, so we're trying to figure out the shortcut for this, and we're trying to figure out, no, but you guys don't know the shortcut yet, so we have to do it the long way.
No.
So, well, we have to find the derivative in order to compare it to the original function, that way we can try to make sure that. So, let's go. So, to find this derivative, we do what? We use what?
F of x plus h.
So we get solid one. I did. So it's not, you don't start there, it's the limit as h approaches 0. F of x plus h plus minus f of x all over h. See? So we have to use this. So all we're going to do is we're going to plug x plus h into this. Alright, so this is going to give us a limit as h approaches 0. 3 times x plus h squared plus 2 times x plus h minus 7. Subtract 3x squared plus 2x minus 7.
Oh, yeah.
All by h.
Shit, why did I turn on look to see what you said? I looked back.
Alright. So, this point, we are going to need to expand this a little bit. So that's equal to the limit as h approaches 0 of 3 times x squared plus 2xh plus h squared plus 2x plus 2h minus 7. Now, make sure we got minus sign over here, so it's going to be minus 2x squared minus 2x plus 7. Right. I already see it. I already see it. I already see the derivative in it. Where? So here, I expanded to x plus h to get this. Here, I just distributed 2. And over here, I distributed minus. Okay? So, here we go. This is equal to the limit as h approaches 0. We have 3x squared. We're going to have plus 6xh plus 3h squared plus 2x plus 2h minus 7 minus 3x squared minus 2x plus 7. All that is around h. If you find the shortcut right here, you still won't be able to use it until I tell you what you do to check the answer.
Here anymore. I don't show anything.
So, what do we do now?
No,
I know you like to take out your x's and h's. First, let's cancel out some stuff. 3x squared is going to cancel out with minus 3x squared. 2x is going to cancel out with minus 2x. Minus 7 is going to cancel out with plus 7. By 7. Yep. By 7. By.
My 7.
Yep.
oh, is that how we got rid of that one?
So we have the limit as h approaches 0. We have 6xh plus 3h squared plus 2h all over h. Now, Shamar, your secondary thing, so your first thing you're going to do is now do what? H's get out of there. Divide h. Divide h. Divide h. Divide h. We have the limit as h approaches 0 is equal to 6x plus 3h plus 2 divide. Now what do we do? 6x plus 3 times 0 plus 2 is equal to 6x plus 2. That is f1 of x. So we got 6x plus 2 is equal to our rate. So,
Okay, so this there was already 3 in the room. We multiply 3 times 6.
this is 60 on.
Because, oh, if you have multiply by 2, like that means that I have
That's a little bit.
oh, yeah, we can put a limit.
Okay. So, over here, we say multiply this 2 by that 3. Then you have to take one away here, so if we multiply that, we get 6, and take away, we get there's only what? So 6x. Well, over here.
Big way.
the, zero, and then you do zero out of it. One times 2 times 1 is 2. Why do you get rid of it? So what could we say now, so what is this term called? Constant, and then, so that constant interval, what about this constant over here? So what can we say about constants in the variables? What's the derivative of a constant? Huh? No, you write that down. That's part of, so the derivative, that's something I learned about on Monday. The derivative of a constant is 0. Did you guys write down a rule for finding the derivative of something raised to the power? So what would we do and say? Okay, so what do you do?
We bring it down.
Bring it down, or like, you have to say bring it down, or you just say. Okay, I know. You're saying bring it down, but what numbers are there? So, over there, 2 times 3.
So you multiply the exponent by the one, no, the one from the number from the exponent.
Okay, so write down that first step. So what do you do?
Oh, you mean like,
I'm not gonna tell you that because I'm not teaching you shorthand.
which one is the first step? Multiply or cancel it?
So the first step is multiply the coefficient by the exponent. And then what do you do next? Can't cancel out the music, with the way, what do you actually do? You guys are saying it better earlier. Look at this one. What do you do here? What do we do to that stuff? So one of you said it earlier. If you're taking away, what's the mathematical you're taking away? Okay, so you subtract what from that? Shortcut here. Functions that have the powers. So, let's just look at this. You can go ahead and do this by hand. So let's do it by hand. What do you think the derivative of this one would be? What do you think the derivative of, I'll give you this is this, so. Oh God.
Oh my, it's so much.
Bad. Really bad.
Oh.
So what would the derivative of this be? So actually, let's just go turn by turn. Here, what would the derivative of this be? Alright, she tomorrow we'll be doing this. I'm subtracting 12. It's really a negative 4. Actually, it's a negative 4. I know. What's the year of this?
It's not.
You see, you guys are paying attention. And this. You know what that answer. You guys ready for one more? I should see. You only did this one, right? You know what to do with this one.
So, my question is, what is one, like you said? What is it?
Is this up here?
Yeah.
That's a constant.
Okay.
Definitely not going. Not going. So, what you guys need to remember is another way to write this.
On one of the two.
Not one of these.
Well,
There is one of those. Now, this is what we can do, and I'm going to just tell you this because I don't think you guys will pull this out of your butts here, is 1 of x squared is equal to x to the negative second power. So this is equal to x to the negative second power. Right? If it said like 3 over x squared, that would be equal to 3x to the negative 2 power. Alright? So, if we're just looking at this one, alright, right here, we're looking at x to the negative second power, what do? Use your rules.
bring down that negative.
Bring it down.
Only I want to be
Okay, so we're going to negative 2 times 1 is negative 2. So it's in there. That's not it.
Wait, no, you already did that.
Take it what? What am I subtracting? Okay, so I'm going to subtract 1 from negative 2, so that's negative 2 minus 1. Now, we don't like negative things, so we're going to put that into the denominator of negative 2 rather than x cubed, which yes. Because one, there, even though you guys know kind of a shortcut, you won't be able to do it. Even if you know the shortcut right now, there's actually another part to this that would require you to know more. Yeah, this one right here you definitely could not do with okay, this one you couldn't do with the shortcut that you know, and this one you can't do with the shortcut that you know. This one you could, but to be honest, you really wouldn't. The shortcut you guys just came up really is only for these types of equations where they are home. Alright? This is a rational function. These ones all require some extra steps. Where you could use a shortcut on this one. You could use a shortcut on number 3, but the thing is, you only would get it right because you got lucky and it doesn't matter what you want to do about it. So the rule that you guys came up with is the rule for polynomial. Find the root of any polynomial. Right? Any polynomial. So we are